Hello, today we are learning about compound inequalities. I know I've got this when I can find the intersection of two sets used by the word and this symbol. Solve compound inequalities containing the word or, and or, and then find the union of two sets or with that symbol. Key vocabulary: compound inequalities, intersection, and a union. So two inequalities joined by the words and or are called compound inequalities. And then basically it's just two inequalities in one. So you can see that here. The solution set of a compound inequality formed by the word and is an intersection. And of the solution sets of the two inequalities, we use the symbol right here to represent intersection. So the intersection of two sets, it's denoted in this area right here where they're both filled out, and you can see this symbol. So it's A intersection with B. A intersect B. So example 1 says if the set of A is X, such that X is odd number greater than 0 but less than 9, and B is 4, 5, 6, 7, 8, find A intersect B. So basically what it's saying is what are numbers in the set of A that's also in the set of B? Okay, so there's the set of numbers in A that's also found in B. So what you can do, you can list all the elements of A, so all the odd numbers greater than 0 but less than 9, and then you can list all the elements of B, 4, 5, 6, 7, 8, and then tell what are the numbers in A that are also in B. So odd numbers that are between 0 and 9 that are also in B. So you would have 5 and 7. So the numbers 5 and 7 are sets. So the intersection is 5, 7 listed in set notation, well, in brackets. So it means it's a set. All right. So if A is the set of all numbers where X is an even integer, B, X is an odd integer, C, 1, 2, 3, 4, D, 3, 4, 5, 6, list the element set C intersect D. So you have to think, what are the numbers in C that are also in D? So you got 1, 2, 3, 4, and you got 3, 4, 5, 6. So you can see that 3 and 4 overlap. So you would say 3 and 4. Okay, here's one for you to do. So C is asking, what is B intersect C? So what are numbers in B that are also in C? So B is odd integers, C is 1, 2, 3, 4. So the odd integers in C would be 1 and 3. And then A intersect B, what are even integers that are also odd integers? And that is no solution because there are no numbers that are even and odd. So I hope you got that right. Okay, 2A, we're going to graph. Okay, so we're graphing inequalities now. So solve X plus 4 is greater than 0 and 4X is greater than 0. All right, so I'm going to solve for X in both of these. So I'm going to subtract 4. So I get X is greater than -4. And divide by 4, 0 divided by 4 is 0. So you get X is greater than 0. So what are numbers that are greater than -4, but are also greater than 0? So you can see greater than 4 in the first line, greater than 0 in the second line. So this red line is going to show where both of those numbers are. So it would be greater than 0. So we go like that. You don't graph the ones like right here because those are not also greater than 0. Okay. 2B, we're going to do the same thing. So we'll divide both sides by 5. You get X is greater than 0. And if I solve for X here, I would add the 4. negative 13 plus 4 is negative 9, divided by 3, you get to get x is less than or equal to negative 3. So what numbers are greater than 0 and also less than or equal to negative 3? Nothing. So the answer is no solution. Okay, 2C, you go ahead and do this one. There are a few, so I'm going to let you do them and then I'll show you. Okay, F and G, you should have graphed x is greater than 2, and G, you should have graphed 3 is less than x and less than 5. So let's see, if I was going to graph this one, I would graph everything that's greater than or equal to negative 3 and also less than 1. So I would have something like this. In D, it's less than 1 and greater than 4. So that would be no solution. There is nothing. Greater than or equal to negative 3 and greater than 2. So you would just graph where you have greater than 2. F would be greater than or equal to 2. So you just put that. And then G, it's in between 3 and 5. So the graph would look like that. To solve a compound inequality written in compact form, such as 3 is less than 5 minus x is less than 9, we get x alone in the middle. We must perform the same operations on all 3 parts of the inequality. So I call these all-in-ones. They're compact inequalities. So we want to isolate the middle part, isolate the variable in the middle. So you can do this 2 ways. You can either break it up like this and write and. You can do it like that and solve both of those individually, or you can just clear out the middle. So I'm going to subtract 5 on all 3 sides. So I get negative 2 is less than negative x is less than 4. And then I have this negative 1. So remember that when you divide by a negative 1, all your signs flip, right? And then you have to write it in order from least to greatest. So you would graph an open circle at negative 4 and at 2, and it would be everything in between there. Okay, 3B, we're going to do this one together. So let's clear out the middle. So first we would add the 1 to all sides. So I get negative 2 is less than 2/3 x is less than 2. And now I can multiply everything by 3/2 to get rid of that 2/3 in the middle. So when I do that, this cancels, and I would get negative 6/2, so negative 3 is less than x is less than 3. So if I draw that, it's going to be open circles, and x is in between. Okay, I want you to try this one, so go ahead and pause it. Okay, if you worked it out, you should have gotten that. Negative 1/3 is less than or equal to x is less than or equal to 3. All right, the solution set of a compound inequality formed by the word or is the union of solution sets of the 2 inequalities. We use the solution, this, to denote union. So the union of 2 sets is everything that belongs to either set. Not both, like, it's not what they have in common, it's just everything they have. So if A equals all odd numbers greater than 0 but less than 9, and B equals 4, 5, 6, 7, and 8. Find A union B. So you would list all of the numbers in element A, so all odds between 0 and 9, and then you look at all numbers in B and you list both. So the numbers that are in either set or both sets are 1, 3, 4, 5, 6, 7, 8. This is the union. Okay, 4B says if A is an even integer, B is an odd integer, and C equals 3, 4, 5, 6, and D equals 4, 5, 6, and 7, list the element of each. Okay, so B union C. So we're looking, so all odd integers, and then 3, 4, 5, 6. All right, so you can't possibly list all the odd integers, right? So you just say X is an odd integer, because you can't list, I mean, there's infinite. Or X equals 4, or X equals 6. So that's how you would have to write it, just because there's infinite numbers that are odd numbers. And there you go. Okay, so you try this one. And all the numbers in C and D are 3, 4, 5, 6, and 7. And all the numbers in A and D are all even numbers, and then 5 and 7. Notice you don't have to list 4 and 6 again, because those are already included in the even integers. Okay, example 5. I'm going to do this one. Let's see. So we're going to solve them individually. Remember, this is a union. So we're listing all the answers. Okay, so we've got 6x is less than or equal to 16. Divide by 6, and you get x equals, or x is less than. You can simplify that by 2, so 8/3. Or I'm going to subtract 2. I'll get x is greater than or equal to 6. Okay, so I'm not just putting what they have in common, I'm listing everything. So 8/3 is 2 2/3, so that's why the red dot is here, 2 2/3, and then I'm doing everything less than that, and then 6 and everything greater than that. Okay, so we're going to do this one together. So we're going to add, we're going to solve both inequalities, so add the 6. So -2x is less than 4. Divide by -2, which you know means flip the sign. X is greater than -2, or divide both sides by 8, x is less than 0. Okay, so x is less than 0. Notice it's an open circle and going that way. Or it's greater than -2, right? So open circle and going this way. What happens? All the shading overlaps each other. So you say the answer is all real numbers. Okay, go ahead and pause the video and you can do these. Okay, and your answers are listed at the bottom. So I know I've got this when I can find the intersection of two sets using the word and the union and the intersect symbol. Solve compound inequalities containing and or, and then find the union of two sets using or and the union symbol. But do you really understand? So explain the difference between the intersection and the union of two sets. The intersection refers to the elements that are common to both. The union refers to all the elements that belong to both. What are the mathematical symbols that represent a union and an intersection? Union's easy because it looks like a U. Intersection is the opposite. Describe the solution sets of x is less than 7 or x is greater than 5. X is less than 7 or x is greater than 5. It would be all real numbers. Now, if it said x is less than 7 and x is greater than 5, it would only be the numbers between 5 and 7. That's it. Thank you.